Welcome to the June 18th, 2018 Kubernetes SIG Apps. My name is Matt Farina. I'll be chairing this meeting today. The meeting minutes and the notes and agenda and everything are in this Google Doc. I just pasted it into chat. So folks, go ahead and head on over and you can see what we're going to talk about today. I just have one announcement. If folks have something they want to demo, we do have the regular weekly demos. If people have things they want to demo, please reach out and let us know. That can be something to do with controllers and app management. It can be something to do with tools that build on top of it to help you operate things. For example, we recently had Casenet as a demo. It can be developer tools like the one we're going to have today. It can be a whole lot of different things. And so if you're interested in demoing something and showing it off to part of the community, please feel free to reach out and let us know. We're happy to have you. And with that, we have our opening demo today, and that would be Radu. Are you here?
Hello, yes, I'm here. Let me know if you can hear me first.
I can hear you, and I can see you, and the floor is yours.
Okay, let me just share my screen real quick. So, let me know if you can see my screen.
I sure can.
Okay, there should be one single screen, right? The VS Code one.
I see a VS Code one, and it looks like I see your whole desktop, it looks like.
Okay, that's great. So for the folks that used to develop monolithic applications like I did back in the day, essentially we had an IDE where we had everything there. So we had the code, we had the logs, we had the metrics, and when there was a problem with their application, what we used to do was simply start debugging. And the IDE was the one place for truth. It was the place that we had everything, right? Now, transitioning to microservice architectures, we have multiple services with so tens of hundreds of services written usually in multiple languages. And essentially what happens is essentially as a community, what we did, we started building tools to emulate that sort of debugging your applications. So the first thing that we started doing in order to debug our application is writing print statements in our application. So if there's anyone that does that or does not do that, please share your hand in Zoom chat. But essentially what we do is we put a print in our application, we build the application, we deploy it, and then we start it. And then with the information that we got from the print statement, we continue developing and debugging the application. But what is missing compared to monolithic applications is the ability to essentially have breakpoint debugging, to put a breakpoint in your application and test to see what happens. So this is exactly what we're trying to achieve with the VS Code Kubernetes extension and draft. And essentially, this is a really simple Golang application. It's a simple web server that reads the host name and then responds with a simple message containing the host name. And essentially, it's just a simple application that will try to deploy to Kubernetes first and then do breakpoint debugging for it. So because it uses draft, it has a Helm chart. So if you're not familiar with draft, I'll just paste the I'll paste the link towards draft packs in chat later. But essentially, a draft application is simply a chart, and it's the only thing special about this is it has a couple of labels and annotations so that draft knows it is a draft application. So it contains a Docker file, so we know how to build the application, and then it has a chart so we can deploy it. And essentially what we're trying to achieve is simply press F5, and we start the process of building the application, pushing it to a container registry, and then upgrading the Helm chart. Either install it or upgrade it if it's not in the cluster. And at this point, what happens is we start the application process, And at this point, draft is going to forward the application ports exposed, will forward it locally. So we have two ports. It's port 8080 where the application is listening. And then there's port 2345, which is the default Delve port. So if you go to localhost 8081, what should happen is we're hitting a breakpoint in our application that lives inside a Kubernetes cluster, and we're able to breakpoint debug it as if it was a local application. So at this point, we're able to see the application request. We can interact with this. In the debug console, for example, we can...
Are we supposed to be seeing your screen?
Yes. Are we not?
No, I see your face.
I
Okay.
see your screen. Is anybody else having trouble seeing it?
I see screen too.
See the screen.
You might have changed your settings in Zoom to lock it to his face or something like that. You might want to switch it from off the default.
Okay.
That should make it easier. I hide my face now. So essentially, right now, you should be able to interact with your application as if it was local. So you can interact with your request. You can see the values. You can change the values in your application, and you can continue. And this is the result that the application should output. Now, usually when we work with microservices, there are multiple services in our application, usually front-end services calling in back-end services, calling in other services. So in this example, we have another microservice. It's a Node.js service, which essentially will create some requests to the Go application that we just saw. So we're doing the same thing for the Node.js application. It's building the image, it's pushing it, and then it's doing a Helm install. And at this point, the debugger is attached to that application as well. And if we go to the other application port, we should be able to debug the Node.js service. And this in turn should create a request to the Go microservice, and we're able to debug that as well. So regardless of how many services you have in your application, you should be able to chain the requests and essentially breakpoint debug through all of your applications. Now, the experience right now, as you can see, it's not ideal in terms that you need 2 VS Code instances, and we're working towards making that in a single one so that you don't have to have multiple instances of VS Code. But essentially, in broad terms, this is the experience that we're working towards, being able to debug applications across multiple services in your app. So if there are any questions so far. Okay, if there are not, I'm gonna do a slightly more real world demo. So the application that we just saw so far were 2 simple microservices. I decided to take a look at a real world application. And I took Helm. Essentially, Helm, the way it's architected for version 2, it has a server-side component called Tiller, and it has a client-side component, which is the Helm CLI. And essentially, if anyone tried to contribute to Helm on version 2, if you're trying to do something on the server side, what's going to happen is you have to build the container manually, push it to the registry, and then upgrade the version of Tiller. So I try to apply the same techniques that we did to the sample Go and Node.js applications to a full application that's used by folks, which is Helm. So I took the Docker file for it, and I simply instead of starting a Tiller, I also did a Delve attach. So this is what you have to do to debug a Golang application, which is start the debugger as well. And essentially, if we do the same thing, which is F5, we should start building the container image, push it to Docker Hub, and then upgrade it and release it in the cluster. So right now, what we're doing, we're using Draft to deploy and debug Helm. And behind the scenes, Draft itself uses Helm. So essentially what we're going to end up with are two instances of Tiller, right? One that is used by draft, which is the production one, and one that we're debugging and one we're iterating against. So when that's ready, we will see debugger attached, and we'll be able to create requests to that instance. So if you're familiar with Tiller, it uses a couple of ports. It uses 44134 to communicate over gRPC with the client, and it uses 44135 for readiness probes and health checks and stuff like that. And we're also forwarding port 2345, which again is the default Delve port for debugging. So we're waiting a bit for the image to be pulled. Let's see what's happening. It's container creating. But essentially, let's take a look at what we need in order to debug, in this case, a Golang application. So by default, the Delve debugger uses, it has to ptrace the running process in order to connect to it. And by default in Docker, which is the default container runtime for Kubernetes, that is disabled by default in the security context. So in order to be able to ptrace a process inside your pod, you have to add the sys ptrace capability in your security context. And this is what we're doing right here. So for other languages, that might be different. For Node.js, for example, you don't have to do anything specific. Just start node -- inspect, and that's it. Yeah, are there any questions so far? Apparently, I already had my port 2345 open from the previous.
There is one open question from chat along the way, tangential to this. What's happening? It says, how does this compare with telepresence in terms of implementation and capability?
Okay, that's a great question. So essentially, what this is doing specifically is it does not modify the networking of either your cluster or your local machine. Essentially, what it does is every time you do an F5, it will build your container image, push it to container registry, and then the draft client will forward all application ports exposed in your Helm chart, in your Kubernetes manifest. It will expose them to your local host. So you can specify this local port mapping. And essentially, when you access local host on either of these ports, every request you create there will be forwarded to your cluster. So this is how behind the scenes the draft and the VS Code extension are using the Kubernetes things to forward requests from your local cluster, from your local machine to the cluster.
So if I understand what you're saying right, it's this application is running inside of a pod, inside of the cluster, and the networking element that you allow is you port forward to be able to access things on there for debugging and interaction.
Yes.
But with telepresence, the application you're working on is actually running locally, and then it networks into the cluster there, right? Is that the difference?
Yeah. That's the main difference. Yeah. With telepresence, you run the process application locally, whereas with draft, you're running the application inside your cluster in a pod, which is essentially the same environment that you're going to run it in production. So this is running, and at this point, you can use Helm as you would normally. You simply pass the host, which is localhost 44134, which will forward your request inside the cluster. So at this point, we should be able to debug the cluster side, server-side component of Helm locally as if it were running locally. So at this point, you can do the same things that we did. It's just a Golang application. You can debug it in the same way as the web application from earlier. And that's pretty much it. One more thing that you can do with VS Code, which is also debug client-side things. So this is the same project, but this time we're debugging the CLI. We're debugging the local component of Helm, and essentially we're doing a Helm list, and we had a breakpoint on the CLI. And then when we continue Helm list, the client side will create a gRPC request to the server-side component, and this is caught in the breakpoint here, and essentially we can debug any sort of client server app side applications with this technique. There's one more question. Is there any way to debug an application that's already running? So it essentially depends on the type of application that it is. Specifically for Node.js, yes, you can do that right now. For Delve, the VS Code implementation of Delve does not allow you to do that. Once you disconnect the debugger, it will stop the process. But that's more of an implementation detail of the Delve adapter for VS Code. Essentially, the end goal is to be able to do that. So far, we're able to debug Node.js, Golang, Python, C, Java. And these are the languages that we tested with. But in theory, you should be able to debug anything that has a remote debugger. And yes, and .NET Core as well. In theory, everything that has a remote debugger protocol should be able to be debugged using this technique, because essentially Draft and VS Code only do the plumbing behind the scenes for your debugger to be able to attach. In the end, if you ever used VS Code to debug applications, in the end, the launch file, the configuration file, is simply a Golang configuration file, or in the case of Node.js, a Node.js configuration file. It's nothing more. It's just before you can attach a debugger, you have to build, push, and release your application, and then attach a debugger and forward the ports. That's, in theory, the things that that we're doing. So, yeah, please. Are there?
There was one other question. There was one other question in chat. It says, "Is there any way to debug an application that's already running?"
As I was saying earlier, it depends on whether the debug adapter supports that. So for Node.js, yes, you can do that. You can do that for .NET Core as well. The implementation for Golang does not currently support that. And you have to restart your pod in order to attach a debugger. Because essentially, when you start the container, you start the process. The debugger process has to start as well. And this is today. So what we're looking for in future Kubernetes versions, so starting with Kubernetes 1.10, you're able to have shared namespaces between the pods of the same, between containers of the same pod. So essentially what we will be doing once every major provider supports Kubernetes 1.10 and the shared process namespace exits alpha, is have debugger in container A and your application in container B, and the goal being to have the deployment files and Docker files for your application while debugging to be as close as possible to your production manifests and charts. So essentially completely separating the debugger and the application from the same container. And when debug containers are a thing, we were hoping for 1.11. Apparently, it will be pushed to the next version of Kubernetes. You'll be able to start temporary containers with your debugger and only have that running while you're debugging, and then stop the temporary container. I'll link all the things that I mentioned in the chat. But does the hot swapping work with Java? The hot swapping, you mean debugging remotely, or having separate containers, one with debugger, the other with your application?
Like debugging remotely, so similar to the local experience as
Yeah, I actually did a test with Java. The only problem that arises with Java is there's a bit more latency compared to what you saw with Golang and Node.js, in terms of it's 1 additional second. But you can do the exact same thing that you did locally. Yeah, that we did with Node.js and Golang.
Thank you.
So if you want to try this stuff out, you can take a look at the Kubernetes extension for VS Code, and you can look at draft. Essentially, everything that I saw you works with the latest version of both the things that I linked to in chat. We'd love for you to give it a try and give us feedback on what you'd like to see and what things we're not doing or we're not doing right. Everything that you saw works with any Kubernetes cluster. It can be either a MiniCube cluster, it can be any sort of cloud-provided Kubernetes cluster, as well as the VS Code Kubernetes extension. So give it a try. I'll be around till the end of this meeting, and I'm always around in the Kubernetes Slack. So thanks.
Thank you. Thank you. This was a great demo. Debugging is one of the things that has been difficult to actually get things running inside of containerized environments. So I'm glad to see people working to solve that problem. Thank you for the demo.
Thanks. Anytime you have questions, let me know.
Yes, so our next step in today's meeting on the agenda is discussion topics, and we're doing the developer tools bi-monthly, so every other week we talk about developer tools and things like that. And the first bullet item we have here is actually debugging. And so, well, we just saw one debugging setup, and another one was touched on, which is telepresence, which you run your application locally. So like I'm on a Mac, and I would run it on the Mac, and then it would connect into the cluster and be able to talk to those microservices. That is another way, because you can debug it locally. Besides those things, or maybe even details on top of those, what else do folks do to debug their applications? Is anybody debugging their apps?
I have a couple of ideas, but I'll let other people have their thoughts heard before I continue.
All right, you might want to go, Radu. I don't hear anybody else speaking up on debugging right now.
Okay. So I've been looking into debugging on top of Kubernetes for a couple of months now. And essentially, if you're looking at tools that work on any Kubernetes cluster that are not linked to a specific instance of a cluster, there aren't that many solutions. So both Google and Microsoft have a solution that debug applications on top of GKE and AKS, but those things only work inside of Google Cloud and Azure. There are Google Stack Drive Debugger for Kubernetes, and there's Azure Dev Spaces for Azure Kubernetes Service. I did not look that much into those solutions, mainly because you're not able to run them elsewhere. For open source solutions that work anywhere, there's also Squash.io, and I really encourage folks to take a look at Squash. The overall experience is what you saw earlier is inspired from Edith Levine's Squash experience. So essentially, you're able to do to debug across microservices using VS Code, and I think there's also a plugin for other IDEs, for other code editors. The main downside that I see, and the main reason that folks try to steer away from Squash, is the fact that you need a privileged daemon set running on your cluster. So you'll have a pod that is privileged and has access to all the processes running on your nodes, simply because the Squash server-side component has to be able to attach to your processes. So while the overall experience is brilliant, and I cannot encourage folks enough to check out Squash and to check out the KubeCon talk from Austin, I think. I'll also link to that in chat. The main downside is the privileged daemon set. Essentially, the first tool that will be able to have the debugging experience across microservices and not require folks to change their deployment files and manifest that significant compared to production or as close to production as possible, is going to be the one that people will mostly use. I assume it's a personal opinion, but this is what we're trying to achieve with VS Code and Draft.
So along the debugging lines, though, I'm starting to wonder. So there's the Open Tracing project, right? Is anybody here using Open Tracing out of curiosity? Does everybody know what it is? So I'll assume some folks don't. So Open Tracing is one of the projects under the CNCF. Grabbing a link for it now. And what Open Tracing does is it allows you to pass down metadata between different microservices. So you can capture a request. So there's Open Tracing, and then the CNCF project, of course, is Jaeger. And the idea is you can, if a request comes in to say your webhead, right, and it comes into your browser or into your JS front end, and then it hits maybe an API server, and then maybe it talks to 2 or 3 backend services, right? How do you trace that request from end to end and know the interactions along the way? And it's distributed tracing. And so there's Jaeger, and I'm dropping some of the links in here. So there's Open Tracing, which is the spec and tooling around it. There's Jaeger, which is an implementation of Open Tracing. And I'm wondering if dependency analysis and anything like this can be used as part of the debugging process. I started to look at this probably a little over a year ago. I was looking at it, but I haven't had a chance to dig in since. I'm wondering, has anybody else looked at Open Tracing, Jaeger? There's Zipkin as well, to see how this works for debugging applications? I'm going to guess silence is nothing. Okay. Yeah, if you're not familiar with Open Tracing and Jaeger, and those are the two. Zipkin is another, and that was, so the first two that I shared were CNCF projects. Zipkin, does anybody remember who put out Zipkin?
I just did a quick GitHub search, and apparently it's Fabricate. Fabricate.io/Kubernetes-Zipkin is the project.
Twitter created Zipkin.
That's what it was. Thank you.
Zipkin comes from a project from Google. It's actually implementation of a white paper from Google. And the gentleman who created that also created another company around Open Tracing as well. Lightstep, that's his name. That's the name of the company.
Yeah. There's Open Census. Yeah, it's basically the ability to just trace and log and understand a request end to end. It's not just for debugging, of course, right? You can do all of this in production systems and development environments. So that way, when something goes awry, you can kind of trace where it goes through everything. And that's where I had looked at it, less than debugging locally, but I'm just wondering how it plays out there. Okay. Does anyone have any other debugging setups they use besides some of the stuff we've talked about? So let me ask this. How many folks find this debugging stuff to be useful, whether it's the demo or some of the other things? Does anybody say, yes, I would use this. In fact, I'm looking for more. I'd be interested in more. Is this kind of a place that's been a problem?
Clearly some bias coming out here a little bit because we actually work on the project, but at the same time, I find this immensely useful. When both Radu and I were working on this, we've actually used the debugger for debugging some, both client-side stuff for Draft as well as Helm and Tiller, just playing around with it and looking through. I think it's immensely useful for debugging and looking at current state and things like that. So for sure, it's a lot better than format.println, which I've been using for like forever and redeploying Tiller and testing logs and whatnot. So valuable for me, at least.
Essentially, for people that come from developing monoliths, and they're used to having their ID, so IntelliJ, and have everything there, breakpoints, logs, traces, metrics, and everything. Coming to Kubernetes and suddenly realizing that there's not a simple way to put a breakpoint and have your application, understand the behavior of your application and step through your code. That seems to make the job a bit more difficult compared to developing monoliths. And this was my initial experience, but I tried to debug an application on top of Kubernetes, and I found myself essentially printing stuff, doing kube control logs, and things that are not specifically directly related to why my application was failing, but trying to gather as much information as possible to understand some of the things around my application. And once your setup suddenly involves ingresses, services, deployments, pods, containers, secrets, config maps, and all other sort of Kubernetes and other projects, so traces and open tracing and chart-related things, it becomes a bit more difficult compared to simply starting and running your monolith locally and having everything in your IDE.
All right, sounds good. So, yeah. So the next topic we had, and does anybody else want to talk more about debugging? Did anyone else have anything more to throw in? I've been throwing some of the notes into the document along the way, the agenda and minutes. I know I missed some stuff, so if folks wanted to go ahead and throw some of that in, please feel free to. The next topic we have up here is actually developer environments. And so the first question was, what do folks actually use for developer environments? Is it MiniCube, Docker? Is it remote clusters? Are you using namespaces, dev pods? Kind of how are folks doing their development setups? Yeah, I'll share mine to open it up. I kind of use two things. I'll either run a I run either local MiniCube, which is kind of my common go-to when I'm doing a lot of quick development, because then I don't have to deal with the network or the internet or things like that. And then I'm one of those folks who's lucky to have, I'll either use something in Google Cloud or Azure is where I have been, but one of the managed services, I'll go spin up a cluster there when I need something larger or I need to share something. And so I'll have a cluster running out there in one of the public clouds, and then I can point people to it or make it route with some DNS that I have, or when it's a larger application that I need to do testing on, I'll run something there. And the same thing kind of applies to CI environments. So anything that I've got a CI on and I want to test operationally, I will have clusters that I'll run, and then CI can deploy to that cluster.
So I had a question. Can folks hear me?
Yeah.
So how do you manage kind of like the local development flow if the app is too big to run on your laptop, for example, or you have some dependency that you can't quite run? You know, you're using some database that's, you know, cloud provider specific or something like that. How are people, I guess, sharding their applications and choosing how and when to point things either locally or remotely if they have to? Is there anybody who has run into that and gotten to a good solution other than, you know, maybe changing config files or something like that?
Vic, the last time I ran an app I was working on that I couldn't fit on my laptop was when I was working on OpenStack. And so it's been a long time since I've had to deal with this. So I can't say. I wonder if somebody else has this, because I know there's some of the larger
maybe even in that case,
like
what did you do in the OpenStack case? I think it's a general question. I think there are many ways to you know, fix those problems, but in general, you have some piece here and some piece over there. How do you manage that? And is that other piece shared, or, you know, how did you deal with that in the OpenStack case?
In my case, we had some shared environments. In fact, I think that's probably what I would do now, is some shared environments where some services that normally would be private are publicly accessible and maybe constrained to the networks and routing locations that they can get to. And then I would talk to those environments. That may also be good if I'm dealing with things like large databases and data sets, and I don't want everybody to have to copy those down or even just have those locally on their systems. And that might be kind of a more secure way for holding all that information, and just expose some of that. So if it's Postgres or MySQL or something like that, just have that accessible, but limited through something, and then make that a configurable element to my application. That's probably what I would do, because for me, developing an application, I'd want to work on my essential business logic, which means the things that aren't that, I'd want to push elsewhere, and then make the instances of those that I use a configurable element for my application. And so that makes it easy to push those other things elsewhere, where I focus locally on the thing that I care about. And
then I think that's a common approach, or at least the one that I've heard of the most, is having some sort of shared service or something like that then you're hitting. The problem that's arises then is, how do you know what the state of that thing is if you are really sharing state? And how do you make sure somebody doesn't screw up a schema or something like that, or doesn't have the ability to do that, but still has the ability to iterate on that piece of the puzzle? So, kind of that environment management question then starts to come up for those shared environments. Does anybody else use shared environments for kind of local development of a piece of their application, and then leveraging some shared infrastructure for the rest of it, or even shared databases or things like that? Sounds like no. And how about on just environment sharing within Kubernetes? Are folks using namespaces to isolate developers within a cluster? Everybody gets their own cluster. Everybody does MiniCube. How are people leveraging that?
So at our place, at my place, we are using dev, staging, and prod namespaces. And we are deploying straight away through Helm charts, and so it is parameterized, so the values are passed upon for the CI/CD environment as well.
And so in dev, you have multiple developers working in dev, or that just goes to a particular branch that then they're committing to?
It's multiple developers are sharing the namespace as a dev. So if something goes wrong with the chart, then we can just delete all the assets in that namespace, and we can again restart.
Perfect.
Yeah, and for databases, we are using at my place we are using AKS. So we initially deployed MongoDB cluster with the replica set, but we faced AKS error for attaching and detaching the disk. So right now we are forging to create another cluster just for MongoDB, and then the application cluster will actually use or consume the MongoDB. So there will be two different clusters.
Gotcha. So it just completely separates the state into
yeah,
its own cluster.
Yeah.
And how many, what's like the shape of your organization? How many developers are you supporting with that setup?
So right now it's around like 30 devs who'll be working on the platform, and there is a solution team which will be inheriting this platform and customizing it. So solution team contains around like 50 people or 50 engineers.
Gotcha. And so your handoff to them is just the Helm chart basically and a new cluster, or are you giving them all of the infrastructure as well?
No, it will be Helm charts, because otherwise it will be pet clusters. So we want to avoid that pattern again, anti-pattern.
Nice. Awesome. Thanks for sharing.
Thanks.
One more approach that can be taken when discussing outside services like databases or messaging systems and stuff like that is to use the open service broker. So essentially within the VS Code Kubernetes extension, you're able to bind to a certain service from the extension itself, and you essentially right-click your chart and say bind to a specific service, and it will automatically fill in the secrets and everything required for your application to run. And what we actually see folks doing is, if you're developing locally, for example, if you're using a SQL service, start with a SQL Server container. And once you're ready to go to another environment, simply switch the Helm chart from the local SQL server to the cloud provided through the open service broker.
And so when you have open service broker usage as kind of a shared or a developer unique instance, how do you populate the developer instance with appropriate data? Does open service broker allow you to kind of have an initialization step before you attach, or how does that work?
Personally, I don't know if the open service has an initialization step. What I personally use when using Draft is Draft tasks, which before deploying the Helm chart allow you to execute things either on your machine or inside the pod. And you can do that in that step.
Is anybody else using open service broker for managing some state across development cycle?
I've looked at it and I've discussed it and I've demoed it, but I haven't done anything more than that, Vic. Because it is one of those things that I too was looking at. You know, if you're going to go portable environments and you need to deal with some of this stuff, the open service broker is kind of nice for those services. And so it's just a little bit further to kind of deal with some of this state stuff there.
Yeah, I think in order to get into that, the problem that open service broker solves, you have to solve a lot of other problems first and have mechanisms for understanding how developers are going to, develop in the first place and share their environments and things like that. So it's probably down the road a bit for some folks.
Mm-hmm.
Regarding to the same, I have one query. So do we have any shared or best practices documented anywhere in the documentation or in community?
The best practices around which part specifically?
The storage and environments and how to...
I don't think I've seen great documentation around that. Matt, do you know of a good spot?
Not that I know of, and I know it's going to be debatable.
Yeah.
Different organizations and different people will do different things, and sometimes different things in different places. Like whether you have staging and QA environments and production and how you separate that. I mean, that can be just a world of difference depending on your organization. So I don't know that there actually is a best practice. I know one practice that I've seen that's pretty common though is if you're using a CI system and you want to go spin up your app, actually just having one Kubernetes cluster that you're running the app in, and then creating a new namespace and sticking the app in there, and then testing it and maybe cleaning up the namespace afterwards. I've seen this happen for both just doing a CI run, also, and then it's torn down after the CI run's done. I've also seen it where a pull request is mapped to a namespace, and so the that namespace is constantly updated anytime new content hits the pull request. And then you've got one place you can always share, and then when the pull request is closed or merged or whatever, then it's cleaned up. I've seen kind of both of those workflows for CI-related activities. But then for developers, I've seen, just MiniCube. I've seen some of them have their own clusters. I've seen some where people share namespaces in kind of a dev cluster. I've seen a little of a bunch of different things, and I don't know if there's a best practice there.
Yeah, I think in the ideal case, everybody wants to be able to just run locally, run everything locally, and then commit, and then have that CI process that you described, Matt. And if it's a GitHub flow with PRs, having an environment there that the reviewer can look at and poke at, I think is super useful. But still on that local side, you kind of depend on the fact that everything can run locally for you. And I don't know that there's great tooling to map these kind of disparate environments or these pieces that don't exactly fit on the laptop or can't run on the laptop.
Yeah.
Yep. Thanks.
Yeah, and there's another concern with MiniCube that was brought up a little earlier in the chat, and I'll just reiterate here. I guess MiniCube does not run Windows containers. It runs Linux containers. And so for anybody who doesn't know, Kubernetes, and I don't know if it's GA or if it's still just beta, can run Windows containers.
Yeah, it's currently beta.
It's beta. Okay, thank you. But it's that ability to do Windows, because now there's Windows containers. So you can have your Windows applications running in Windows containers and Windows servers. Kubernetes supports that as a beta feature. But MiniCube doesn't let you do that locally. So if you're going to do development on that, you've got to be somewhere else that supports the Windows.
Yeah, and probably the most minimal setup that I've used today is to just set up a single Linux VM with kubeadm and then just join my Windows laptop to that VM. And that works.
One thing that I could mention, if you're trying to test Windows containers, is virtual Cubelet. It allows you essentially to have your either a MiniCube or an actual cluster. And if you happen to have an Azure subscription, you can spawn Windows containers in the ACI, in Azure Container Instances. And essentially, you wouldn't necessarily need an entire Windows host for this.
Yeah, but for local development, it sounds like MiniCube supporting Windows containers would be kind of slick. Okay. No, this is all great.
I have one more question. What is the usual workflow when you're trying to onboard a new developer on your team, which is working on Kubernetes? What are the steps involved? In terms of giving access to cluster, giving access to repos, the overall environment, the entire development environment, from actually being able to deploy to the cluster all the way to pushing to a repository.
So I'm going to ask if folks even have stories of non-ideal situations and things you learned, please share those. I'll share our non-ideal situation that at least I went through. I haven't looked at it. Is I got credentials to public clouds to go create my own clusters. And then I got access to the code, which of course had Helm charts and configuration files and things like that, and go run free. But I also knew Kubernetes coming in, and I'm not sure what it is to onboard folks to Kubernetes, which is kind of a hard problem right now. There's been a number of things written about Kubernetes being hard and complicated. And then there's some companies like, I want to say Stripe and some others who've talked about removing the complicated Kubernetes bits away from people and giving them a simpler interface. And I think in Stripes, they were talking about cron runs and coming up with a simpler interface and then turning that into cron jobs behind the scenes for people. But there's stuff like that going on to try to simplify it, as well as it's kind of hard and hand-holding and taking time in docs. If folks have better ideas on how they did it, what I've gone through is very, very messy. I'd love to hear it.
So am I coming in clearly right now?
Crystal.
All right. So this is actually one of the real goals of KSonnet is that it'll democratize the environment and allow experts to do expert things, but allow neophytes to do pretty much everything else, which is all the day-to-day stuff. So this is why we are putting in the work on that, to remove the complexity of a lot of the complexities of Kubernetes beyond what a normal operation or a normal operator would have to see day to day.
So just out of curiosity here, right? So KSonnet, and you can go use scaffold and draft. You've got the config files. You can just start running your application and then iterating on it, right? Because somebody else who's working on the application may have already created your Kubernetes file or your Helm chart and things like that. So you can go iterate on your application. But there's also that onboarding of how does somebody go get a Kubernetes environment to work in and get access to it? And then what kind of access do you give them to that development cluster, right? So there's all that stuff that's kind of maybe sidestepping the tooling too, as far as onboarding. And what assumptions do they know about Kubernetes? Do they know what a namespace is or a pod is in the first place? Like that's one of the things I totally take for granted. But when we've got noobs starting, and I'm sorry, there's probably a nicer name, but when we got new people starting, do they even know what a pod is? And do they understand how containers work within a pod and how that's attached to the network and how the scaling works? There's so many Kubernetes-isms that I think we get when you want to onboard new people that's a hard part right there because we're so down the rabbit hole.
Yeah, I think there's definitely a baseline of knowledge you have to have. I don't think you can avoid Kubernetes 101 no matter what level of abstraction you're going to provide to your developers. But then definitely I think pointing them towards, I guess, the pieces of what is in code that they need to understand and look after, and then giving them a way to iterate on those things. I found that giving developers a way to see their changes and understand, like through screwing things up and changing things, you start to understand how the system works more. So giving them the tools to iterate and pointing them in the right directions to change things. Like, I think everybody, if they pick up a new project and they want to, add a new feature, they're first going to just go and try to figure out how do I add a log statement somewhere and make sure that I am actually changing the code. So that kind of level of onboarding, I think, is going to be important after the Kubernetes 101 is add a log line, iterate, and then just start changing things and feel free to kind of break things in a, I guess, isolated environment.
And then when we're discussing different levels of abstraction, usually abstractions come with opinions. And the question is, how flexible do we have to make the environment for new developers versus how easier should it be compared to just letting them use kubectl and lower level things?
So I'm going to get maybe a little opinionated here. We got to make it simpler. There have been a number of posts talking about how things are complicated. And even I found the blog post that Stripe had. If you go look at it, they built their Kubernetes cluster to run cron jobs, and they don't actually open up Kubernetes cron to people. They actually have, if you look for the heading, making cron jobs easy to use, there's a section on what they're doing because they don't want their developers to have to learn Kubernetes or even go through Kubernetes 101 or learn the different types of controllers. They're trying to make it simple to do that way, right? And that's, with other platforms, it tends to be a little simpler. And Kubernetes, there's been a lot written on how it's complicated, which makes the onboarding process complicated. And so I'll be honest here, right? I work at Samsung. And so Samsung has thousands and thousands and thousands of software developers. And so if we want them to run their stuff in Kubernetes, that's thousands and thousands and thousands of people who've got to go through Kubernetes 101, right? Or more. And then how many hours do they each have to do on it? Say it takes them 8 hours to get through that. That's 8 times thousands and thousands and thousands of people. And so that's what the enterprise is going to grapple with. And so that onboarding is actually a huge cost thing, right? And so Kubernetes is hard. Or if I went to Cloud Foundry, I can probably do a 101 deploy an app for a developer here in couple of minutes. They can get going on it. They can read some code and get going. It's a lot more complicated in Kubernetes than something like that.
So,
I understand they're different kinds of platforms. I get it. They're different kinds of platforms. But that onboarding experience and making that simple matters.
Yeah, but Matt, Cloud Foundry is looked at more as a PaaS. Kubernetes is a platform or platforms, which I would liken to more of Linux and Linux distribution. So, but we do expect our developers to, if they're deploying to Linux or if they're deploying to Windows, to have at least a bit of understanding of the underlying platform. And we're going to have to do that with Kubernetes unless we're going to relegate it to PaaS status, which isn't going to happen.
But we can also look for ways to make the experience and the onboarding easy, because the onboarding is hard and the experience is hard. And it's a complaint, and a lot's being written.
And a lot can be done. I think every organization will have some set of documentation that is for developer onboarding, and that may be 3 pages that just says clone this, run this command, run this bash script, and now you're deployed. And that's great. That is an onboarding documentation, and now they can iterate on the application. But when they want to dig deeper and start to send pull requests to changing core infrastructure code, at some point they're going to have to start learning some of what they're changing. And so I don't think we'll be able to get away from that. And to Brian's analogy to Linux, I didn't learn Linux when I showed up at my first job using Linux. I slowly kind of chipped away and learned little pieces of it as I got there. I think over time, we'll see that be more the case where you've seen little chunks of Kubernetes, or it's kind of in the headspace a little bit more. Right now, we just have this huge leap from 0 to 60. And I think making that onboarding and the knowledge transfer of that 101 as easy as possible, and having a well-known path to get to not proficient, but to understand what you're changing in some way, shape, or form is going to be really useful and necessary for a while. I don't think we can just skip over that today.
No, but we're also getting into kind of the separation between app developers and app operators, right? Most Node.js developers don't have a clue how systemd works on Linux today, and they don't need to, right, to do any of their app stuff ever. In fact, they can even deploy it to a lot of places and not have to deal with that. And so I'm hoping we start to see more tools built on top of Kubernetes that makes it easy for people to do these things and even deploy production level stuff without having to know how it is. Because lots of Node.js developers, without understanding how systemd works, can go spin up massive web services that build business stuff without having to learn all of this stuff that isn't related to the business logic of their applications. Because once we break them outside of that, it is now extra work outside of getting their stuff done, and it's a different space. And so that app operation space, how can we automate as much of that as possible and make the onboarding to it so simple that app developers only have to worry about their business logic, and a lot of the rest of the stuff, there's tooling and other things that makes their life simple. Because if we ask them to learn a lot, that one slows them down, because they're now saying, I'm not going to touch my business logic. I'm not going to go learn this other stuff, right, and deal with getting my features and stuff done. I'm going to go learn something that's not related to that. Then I'm going to go operate it and deal with it and dig into it and go write codes and deal with the YAML and all this other stuff, because it's hard, right? And so, one of the things, it's one of the reasons for all the SaaS services these days, right, is because I want to focus on my business logic and not on all the other parts. So I can just focus there. It's a huge thing. If you go poll like companies, they're interested in developer velocity and flexibility and things like that. And to get velocity, you got to focus on your business logic, not the other stuff. And so if you got automation that can do that, so you don't have to, that's a huge win. And that's an easier onboarding experience.
Well, why can't they do that today with Kubernetes? It's the same thing, right? If you mask the entire, post-code commit process, then you can do that with Kubernetes today, and you separate the operators from the app developers, and you're in the same world that you were in, before. You write your Node.js stuff, you run it locally, you write some unit tests, you commit, and then it goes off and goes into a pipeline that you may or may not care about. I think that's still a viable world if that's the world you want to live in, right?
But our tooling around that, I would argue, is lacking compared to other things, right?
Why so?
Why is it lacking? So if you were going to go, let's say you're going to do the Node.js app, right? And I'm going to deploy it to, say, Heroku, or I'm going to deploy it in a Kubernetes cluster. What do I need to know that's different in order to do these things, right?
Why do I care where it's being deployed? That's what I'm saying. Like, if there's a divide, deploy is commit, for most places, and then it goes into a review process, then goes into a QA system, and the QA system does some automated tests, and there's some manual validation and perf testing, and then pushed out to production.
And who creates that whole system, though, right? Because today I go to Node.js with Travis CI and deploy it to Heroku from there, and an app developer not needing to know much else can make all of that work. But if they got to go deal with Kubernetes, it gets far more complicated. So what I'm just saying is there's a space where we can still make more tooling to make stuff easier for people, right? Because right now I go to Travis, I go to Circle CI, I can have my Node.js app, I can easily deploy it there with simple APIs and add-ons. But if I'm going to go do this to Kubernetes now, it's far more complicated. You have to have an operator, whereas with Node.js, I may not even have to have one, because the automation and the default templates and everything are there to just tell me what to do, so I don't have to think. But with Kubernetes, there's still more knowledge somebody has to deal with. So you're even saying you have to have an operator. And there's a lot of people who don't want to have to deal with that, right? So how do we make it simpler for those cases where it needs to be simpler, which makes the whole onboarding simpler? And it's more shareable, because it's not different companies coming off with one-off onboardings. It's general tools that can now be shared between companies, so each company doesn't have to go figure it out, right?
So are you advocating that there should be the path on top of Kubernetes that we can all agree on, that is that easy layer? Or are you saying that there should be incremental pieces that then can be built into a path, so that there's the missing piece? there.
I
Because
think
I don't think adding a bunch of extra incremental pieces on top of Kubernetes that make building a PaaS easier gets us there. But if there was a PaaS, it sounded like you were very much advocating that PaaS is the way that app developers should deploy this.
no, because there's different ways. I mean, Draft is not a PaaS, but Draft replicates a lot of what PaaSes do by auto detection and generating things for you, right? It's not exactly a PaaS, but it gets along the same lines, and it uses Helm and other stuff to deploy and operate it. So it gets into some of those similar ideas. What I think is that space of making things very simple and easy to understand and easier to follow to don't make me think needs more solutions. I don't want anything to be baked into Kubernetes itself, and I don't know the right answer, and there's probably more than one, just like we have Vim versus Emacs debates, right? Versus Atom versus Visual Studio Code versus Pico or whatever. Oh, yeah, thank you for the time check, by the way. I think it would be nice to see tools that went into that space and tried to solve those problems, and then we get to see what gets uptake. But it's all about making that onboarding and that experience easier. So thank you. Yes, we are after time, and so I'll call time on the meeting. Thank you everybody for coming, and we'll be back here same time next week. So thanks everyone for a lively discussion, and the recording will be online shortly this time. Shortly. Thanks everyone.